Hello guys, welcome to the channel. Today's problem is Geek's Village and Wells. So let's see what it says. Here is the problem. It says that Geek's Village is represented by 2D matrix of characters of size n cross m. Now there are four type of values in the village. The first one is H, which represents a house. The second value is W, which represents a well. The third value is dot, which represents an open ground, and the fourth value is N, which means prohibited area. We are not allowed to enter in this area. Now it says that every house in the village needs to take water from the well. Okay, so there is a story given. Let me explain it. I am going to take the example of a village, and here I am going to write values as H, 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 then W, then let's say we have W, then we have N, 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 and after this we have dot, which means open ground, then we have H and W. Okay, so in this matrix you can see that each value H is basically representing a family, and each family needs to take water from the well, and as the family members are busy, so they need to take the water in the minimum time. And when I say minimum time, this means that I'm actually talking about minimizing the distance between the well and the house, because this is automatically going to minimize the time, right? Fine, but hold on, we have not talked about how to get water from the well. Let's see. Let's say I have one house here and I have one well here. So from this house, one of the family member is going to pick the bucket, and then he will go all the way to this well. After this, he is going to fill the bucket of water. Then it will carry that bucket back to the house again. So this way, you can notice one thing, that if this particular distance is d, then the total distance that this person has traveled is going to be 2d. This is very important observation here. Now, the second thing that I need to tell you is how the person is going to move. What are the movements possible? So let's say I'm at a particular house. Let's say this is the house, and this house is at index I and j. So from this house, a person can go to the cell which is directly up from this house. He can go to this particular cell as well in the left direction. He can go to the cell in the right direction, and he can go to a particular cell in the down direction. This way you can see that uh, if I go to the upward direction, then I'm actually moving upward. So this means that the row number is going to decrease. So I is row number, so this will be I minus 1 and j here, this particular cell. And this cell will be, when I move backward, then I'm actually decreasing the column. Like this is column, let's say 0 1 2, and this is column 1, right? So moving left means I'm decreasing the column, so it is I and j minus 1. And moving right means increasing the column, so it is I and j plus 1. Similarly, if I go down, then if this is decreasing the row, then moving down means increasing the row number, so it will be I plus 1 and j. These are the movements that we have. Fine. Now, one more thing is this particular note. This note says that all the cell containing n, w, and dot, the answer should be 0. Why? This is even obvious that we know that every house needs to take water. So every value other than house is going to have the answer 0. By why? Because this value doesn't going to take any water, right? And for all the houses where there is no possibility of taking water, the answer should be minus 1. Let's say we have the structure like H, then we have N, 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 something like this. You can see that this house is surrounded by all the prohibited areas. So any person in this house is not allowed to move like out of this area. So in that case, this house will not be able to get the water, and the answer for this house will be minus 1. I hope this makes sense to you. Now one example is given here. Let me explain the example. The example says that we have H, 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 then we have H, W, again H, then we have values like this. Now for this house, the distance of this particular well from this house is going to be like moving down and then moving right. So this is 2, and when the distance is 2, then the total distance that the person needs to travel is going to be 2d, which is 4. What about this house? For this house, the distance is 1, so the answer will be 2. For this house, again the distance is 2, so the answer will be 4. Similarly, for these houses as well, the structure is very symmetric to the house which are here. So the answer will be 1 for this. So I'll store 2 here, and for this I'll store, okay, for this I'll store again 4, and for this I'll store 4. What about these two values? For these two values I will write 2 here and 2 here. And what about this well itself? For this well itself, you can see that the answer is going to be 0. This is what the answer is for this particular test case. Now I hope you have understood the problem well. So let's talk about the solution. Okay, here I have taken one example, and for this example, let's talk about this particular area. Let's talk about this area. For this area, until now we have figured out one thing, that for each house, we just need to find the nearest well, right? And once we have found the distance of nearest well, then the answer is simple, which is 2D. So for each house, whenever we have a house, for each house, we can just find the distance of nearest well. And this is how we can solve the problem. But hold on. How to find the distance of the nearest well? This is the question. Distance of nearest well. Distance of nearest well. Okay, so whenever it comes to finding the shortest distance or the nearest distance in case of a grid, then make sure that the first thing that comes to your mind is BFS. BFS traversal is basically the best first search traversal which is best used for finding the shortest distance. Now, what we can do is, okay, so this is enough for you if you don't know about BFS, because in this particular video I will go in detail about this approach using BFS. Fine. So for this house, for every house we can find the distance. So for this house, if I perform BFS, then the distance will be 2 and the answer will be 4. Similarly for this house, again the distance will be 1 and the answer will be 2. Again I will perform BFS for this house, then again I will perform BFS for this house and for this house. You can see one thing, that I am performing BFS 5 times here. Is this optimal? Is this optimal? Let me explain. So we can do the same task in just one BFS traversal. So now I can say that this is not something optimal. We can do something better, right? So let's see how we can do the same thing in just one BFS traversal. I'm going to write this way, these values here. So I have W, then I have H, then I have H, again I have dot here, I have dot here, and I have H here, and then I have dot here. These are the values that I have. So one thing that you need to know is, if this is a house and this is a well, so either I go from this house to this well, or I go from this well to this house, the distance is going to remain same, right? So instead of going to the well from each house, I can start from the well itself, and from this well I can just perform the BFS traversal, and this is automatically going to assign the minimum distance to each house. Make sense? Let's see how we can do this. So I'm going to start from this particular index. Let's say this is 1 comma 1, and the initial value is going to be 0. 0 means the distance of this well from itself is 0, right? After this, we will go to the neighbors. We will go to the neighbors. And when we go to the neighbors, then we will increment this particular value, which is distance by 1. Because now we have traveled one distance, right? So for these values, the answer is going to be 1. Okay. Now from this value itself, again I can go to the neighbors. Again I can go to the neighbors, and when I go to the neighbors, then distance is again going to increase by 1. So for this, the distance will become 2. Now you can see that how easy it is to find the distance of every house from the well in just one BFS traversal. So this is what we can do. This is what we can do. But this is about one well, right? And if I talk about this whole example, then we have not found the answer for this particular house and for these houses as well. So what we can do is, we can store the index of each particular well. From this house, it is not possible to reach this well, and from this house I can go to this well, right? So I'm going to store the index of each well in a queue. Why queue? Because whenever it comes to performing the BFS, then we always use queue, which is first in first out kind of data structure. Fine. So we are going to store the index of each value in the queue, and in the same manner that I have explained you. First I, then j, then I will store the distance, which is 0. Then I will again have the coordinate of this queue, then this queue, this well and this well, right? So this is what the approach looks like. Let me show you the approach. You can see that I have divided the approach into 4 parts. The first part is initializing the queue and initializing my answer array, which is going to store the answer. Because when we talked about this particular thing, let me explain you. So for this, I want to show you one thing. Okay, so you can see that we have some distance here, right? And we need to store these distances somewhere in the answer. So this is where this answer array comes to play its role. We are going to store the answer in this particular answer array. Fine. And initially I'm initializing this value with the values in the answer array by maximum values possible. Why? Because I want to minimize the distance, right? So every time I'll just check whether my new distance is minimum or not. So first of all, I can do this task. After this, I can store whenever I have a queue in the grid, I'm traversing the grid here, and whenever I have W in the grid, which means a well, then I'm going to store that particular value in the queue, right? And in this form. Fine. After this, I can perform the BFS as I have the queue filled by values now. And when I perform the values, in the fourth step, I can check one thing, that if my answer is equal to max value till now, after performing BFS, this means that we are not that house is not able to like get the water, right? So in that case, I need to make the answer -1. And there is one more case, that if the value is n or dot or w, in that case answer is going to be 0. So this is what we can do, and at last we can just return the answer. We can return the answer. So these are the steps that we need to follow in order to solve the problem. Now let's talk about how BFS is going to work. So here we are going to talk in detail about BFS. For BFS, the first thing is, what are the movements that are allowed to us? The first movement is upward, and then left direction, right direction, and then downward direction. These are the four movements. Fine. And if I talk about this particular example, then my Q will have values which is 1 comma 1 comma 0, right? Fine. So I'll perform the BFS while my Q is not empty. So while Q is not empty, Q is not empty, I need to perform BFS, right? So how to perform BFS? Initially this queue has this value, so I will pop this value out. So I will get value value equal to q dot poll, or I will say q dot pop. This makes more sense here. Fine. So once I have these value, so I can get the I index, j index, and the distance, right? So I will get these values. So I comma j comma distance is going to be fetch from this particular value, right? This is how I am going to represent it. Once I have these indices, what I can do is I can go to these four direction. I hope it makes sense to you. So I can go to these four direction. There are multiple ways. The first way to move to all these four direction is manually checking I minus 1. Okay, so let me erase this. The first way that I have is, the first way is, first I will go I minus 1 and j. This is the thing I will check. Then I will check I plus 1 and j. Then I will check okay, I and j plus 1. And then I will check I and j minus 1, right? Okay, can I write this value again as I minus 1 comma j plus 0? Then I have I plus 1 comma j plus 0. Then I have I plus 0 and j plus 1. Then I have I plus 0 and j minus 1. Can I rewrite these values as like this? Of course I can write, right? So from these values I can simply remove this I and j, and when I do so, then I will have values like, -1 0. Then again I have 1 and 0. Then I have 0 and 1. And then I have 0 and -1. These are the values I have, and these values are needed to be added to I, and these values are needed to be added to j. Okay, so I can store these values somewhere in the list, and if I store these value like -1 1 and 0 0, I can store this value in dx, which means direction x, and dy means direction y, and I can store in this as 0 0. Then I have then I have 1 and -1, right? So I have these two arrays, and see how smartly I can traverse all the direction. So I'm going to start a loop from I equals to 0 to I smaller than 4 I plus plus. Why 0 to 4? Because there are four directions possible, and for each direction I'm going to get my new coordinates as my new I will be, how I can get, simply I plus this value and j plus this value. So I'll write I plus dx of I. Okay, so this not I, let's say this is x, because I will give me repeated value. I have I already here, right? So dx of x, and then n of j is going to be j plus dy of x. I hope it makes sense to you till now. Okay, now what I need to check here, what I need to check here, inside this I need to check very important condition. First of all, I will check whether these I and j, whether these new I and j are in the range, like are in the matrix boundary. Let's see what it means. Since for this take this example, when I'm at this particular index, so for this I can go here, I can go down, but I can't go left. When I try to go left, and or even when I try to go upward, then I will go out of bound, right? So I need to check this condition. If my ni uh, and nj are like in the boundary, I'm not going to write the specific code because I can show the same thing in the code. So I'm just writing the idea that if ni and ng are in boundary, and the values from this w, I can only go to h, or I can go to a ground, an empty ground, right? If I have an empty ground here, so I can go to the ground, and even from this edge I can go to h, or I can go to ground. I can't go to values like n or w, right? Okay, so I can write this logic. If my grid of ij and even new I and new j is equal to either h or the empty ground, in that case I can add these values, right? But I need to check one more condition. I need to check one more condition. This is very important to understand. Just focus here what I'm saying. Okay, so let me remove these values. What I mean is, from this h, let's say from this h, uh, from this w I come here, and then from this point dot, from this empty ground I go to here. So from this h, if I try to move right direction again, then you can see that I'm repeating this value, right? And why to repeat this value if I'm coming from this path itself? So if I go from this is distance 0 and this is distance 1 and this is distance 2, so if I again come to this value, then the distance will become 3. But you can see that this distance is already smaller than this 3, right? So this means that I can either go to this dot from this w itself, or I can pass from this dot and then I can again come to this dot. So this is not something optimal. So we can check one condition. If my answer of I and answer of j, if my answer of new I and new j is something which is smaller than, okay, if this value is something which is greater than, if this value is greater than what, greater than this particular distance, I will get some distance from this, right? So I will get the distance as d plus 2. Why d plus 2? Why d plus 2? I will always increment the distance by d plus 2, because whenever I like, let's say from this w I go here, so you can see that I need to increment my distance with 2. Why? Because I'm traveling the same distance two times. You can see that the intuition comes from this particular part. Okay, so I'll increment my distance by 2, and if this value is something which is greater, in that case I need to rewrite this value as ni and j will become d plus 2 here. Okay, and I will add this value in the q as well. So I will add q dot add, I will add the value in the q, which is new I, new j, and distance plus 2. This is the new updated value. Only in that case I am going to add the value in the q, and this is how I am going to perform the bfs. Now I hope the idea behind bfs is also clear to you. And even if I talk about this condition, so let's say for this let's say I'm at this particular point, and from for this point you can see that the distance from this w is 2, right? And when I perform the bfs from this particular w, you can see that from this well I can go to this h in just one distance, but the distance is already 2 here. So when I check this condition, in that case I will go to this h, and from this h these distance are again going to be modified if required, right? So this is how we can perform the bfs. Now let me show you the code. Okay, so on the left hand side I have the Java code, and on the right hand side I have the C++ code. And you can see that the approach is very similar to the one I have explained you. First of all, I am initializing my result array, and then this result array is going to have in maximum value. You can see here I'm assigning maximum value. After this I'm making a queue, and for this queue I'm adding all the values which are w in the queue, right? And we are performing this operation as well, and this I have already explained you. And this is the point where I'm performing the BFS. And how BFS is being performed, you can see that I'm moving all the direction, and I have again the direction array which is like this. So here I'm using the 2D array, but the one I have explained you was two different arrays, so you can get those array from this particular code, and the concept is going to remain same for both, right? So again you can see that I'm going to all the direction, and then I'm only pushing the value if these are in range. This is for the in range, and again I'm checking if it is not equal to n. And even I can check one more thing. This is not something optimal. I can optimize it by checking if the value is even not equal to w, right? So and grid of like x and y is not equal to w. This is what optimizations we can do. Fine. So now you can see that at last I'm doing the same thing that I've explained you. I'm just checking. Okay, see here. This is something different, but here I'm doing the same thing. You can see the one I have explained you. Okay, so now I hope the idea is clear to you. This is all about the approach. If you guys like the explanation, then you can hit the like button, and if you are new here, then you can hit the subscribe button. You can check out yesterday's problem of the day as well in the like card which is showing in your video. Thank you.